This is the second half of lesson 5.1. And in the first half, we talked about making dot plots to display numerical data. In this section, we're going to learn about histograms. Now, histograms, when we make these, we typically divide our data values into classes that are equal width. You typically want to have between 5 and 10 classes. And I'll show you some examples in just a few minutes about why you don't want to have too many or too few. The heights of your bars will represent the number of data values in each of those classes. So that's showing you a count or frequency. However, we also can show the relative frequencies or percents of the data in each class, and we'll kind of look at both of those. Now, histograms work best for continuous numerical variables, and they also can be used for discrete variables if your data set is very large. Basically, what you're going to do with a histogram is you're going to group data values together that are similar, and that just makes making your graphs a little bit more efficient. So we have here a data set that is showing reaction times. So maybe you have a class of students that's participating in some sort of experiment and we're recording reaction times. And I have taken this data and already arranged it for you from smallest to largest so we can focus a little bit more on the process of making a histogram and some of the important things that we need to look for. So first of all, notice the chart that's set up here for you. I've already filled in the classes. And the classes here, we have 6 of them because there are 6 rows in this table, and each class has a width of 5. So notice this one goes from 0 to 5, the second one goes from 5 to 10, 10 to 15, and so on. And it's very important that these are consistent. You'll also notice that we've written these with inequality symbols. And here we have the or equal to symbol, less than or equal to. This one is just less than. And that's also important because this first class goes up to 5, but does not include it. The second one is where the 5 is included. And why that's important is because if you look at our data set, we actually have data values that are right on that class border. So we need to know which class those 5s are going to fall into. So the second column here where it says frequency, that's where we're going to count up how many data values are in each of our classes. And then with relative frequency, we're going to calculate the percents. So it's already set up for us. All we have to do is go through and count up and figure out how many data values go into each of those classes. So let's start with the first class from 0 to 5. 0 to 5 means everything from 0 and up to, but not including 5. And we only have one data value here that would fit into that class, and that's the 3. So for our frequency, then we would put a frequency of 1. Now the next one is 5 to 10. 5 to 10 means start at and include the 5s, right? So we're going to include that whole row, and we want to go all the way up to the 9, and that's where we're going to start, because when we get to the 10 is going to be part of this class because that's the one that has the or equal to there. So if we count all of those up, we end up with 15. Now, I would recommend that you pause the video and count up the rest of those just to kind of practice figuring out which data values fall into which class. All right, with the next one, we ended up with 25, and then we have 15, and then 2 in each of the last 2 classes. Now, I would add up all those frequencies, and just to double check. And when I added those numbers together, I came up with 60. And you can go back and match that up against the data that you're given to make sure that you actually have 60 data values. And that's just kind of a good way to check to make sure that you didn't miss any or count any values more than once. Now, for relative frequency, then we're going to calculate percents. So for the first class, we have one data value out of the 60 data values in our table, and 1 out of 60 is 0.017. So that's pretty small. It's about 1.7%. 15 out of 60 is 25%. And then we're just going to go through and turn all of those into percents, and we're going to keep 3 decimal places on each of them. Just that's because that's typically what we do with percents. Now we can go ahead and make our histogram. And I'm going to make a relative frequency histogram in this case. I'm going to put my reaction times on the horizontal axis, and I'm going to label like this. So my class width was 5, and that will be the interval that I use on my horizontal axis. And notice that I'm not labeling 0 to 5, 5 to 10, 10 to 15, and so on. I'm just labeling it like a consistent numerical scale, and they're equally spaced. Now, my vertical scale, then I'm going to put relative frequencies, which are the percentages. My biggest percentage was just a little bit above 40%. So I'm just going to label this way, and my tallest bar will go a little bit above the top, but that's okay. You could also number and just do point 0.1, point 0.2, point 0.3 on each of the bars that are on your graph. However you want to do that is fine, as long as it fits on there mostly. Now, my first class, remember, went from 0 to 5, even though I only had one value in there and it was a 3. I'm going to make my first bar stretch all the way from 0 to 5. And that has to have a height of 0.017. So just kind of do your best to estimate approximately where that would be. And with histograms, it's really important that your bar fits the entire class. Again, even though there's only one value in there and we know it's at 3, the bar represents the entire class. And that's one of the problems with histograms, is that when you look at this bar, we know that there's just a little bit of data in that range, but if we just have the histogram, we can't tell whether that data value is at 0 or at 1 or at 3 or 4.5. So we sort of lose that individual information about our data. Now, our second bar was at 25%. And that one goes from 5 to 10. And notice that there's no gaps between the bars in histograms like there are with bar graphs. The next one was the one that was a little bit above 40%. 25%, and so on. So we'll just go ahead and fill in the rest of those bars. Now, here are two histograms side by side showing that same data. And notice the one on the left, I have graphed frequency. So you'll notice over here it says frequency on the vertical axis. And here I've graphed the counts. So for example, we had one data value from 0 to 5. We had 15 data values from 5 to 10. And this is showing us the counts. Over here, we're doing percentages or relative frequencies. And notice that these graphs essentially look identical to each other. The only thing that's different is the vertical scale. Here's one where I did more classes. So here my class width is 2. I'm going from 2 to 4, 4 to 6, 6 to 8, and so on. So I end up with narrower bars, but there are more of them. And this one is also okay. This might be a little bit more than 10 classes, but it still is giving us a pretty good picture of how this data is distributed. Here's one where we're doing a class width of 1, and this would be one that would definitely be a no-no. Doing a class width of 1 is essentially the same as making a dot plot, and there's just too many data points here to do that. So, I mean, you could make a dot plot, but if you're going to do that, then you might as well just make a dot plot and not take the time to draw a histogram. So this would be a no-no. And then this is one where we only have 2 classes and our class width is very large. This would also be a no-no because you're really kind of losing the shape of how your data is distributed here. And there's just too much information about your data that you can't tell by looking at a histogram with only 2 bars. So again, try to stick with between 5 or 10 bars. You don't really want to go above or below that in most cases. Now, once we make histograms, often what we want to do is talk about the overall shape of the distribution, and we're going to now discuss some common shapes that you'll see. And you have to keep in mind that when you're graphing actual data, your shapes are never going to be perfect. So you have to think about approximate shapes. So the first one is what we would call a symmetric distribution. Here we see that the left and right side of the graphs are approximately mirror images of each other. And again, it's not perfect, right? We can see that there's kind of a little bit more of a bump in the graph here that maybe we don't have on this side. That's okay, but it's approximately the same on both sides, so we would say that's symmetric. Now in number 2, we have what would be called a uniform graph. Here we have heights of the bars that are approximately the same. Again, not exact, but they're pretty close. You might also say that that second graph is also symmetric. So it happens to be uniform and symmetric. And sometimes graphs will take on more than one shape, and that's okay. Here we have graphs where the data is more piled up on one side than the other. So in number 3, more of the data is piled up on the left and we sort of have a tail to the right. Here we would say that that graph is skewed right. Whichever direction the tail is going is which way the graph is skewed. And in number 4, the more of the data is piled up to the right and we have a tail going to the left, even though it's not as obvious as the first one, that one we would say is skewed to the left. Now notice those are not symmetric. The left and the right side of the graphs definitely do not match there. So here we would probably only have just skewed as the appropriate shape. Now, sometimes we also talk about the number of peaks that a data set has. That might be important to us for some reason. And in number 5, we have a graph that's kind of symmetric. The peak is a little bit off center, but it definitely has one distinct peak. So here we would say that this graph is unimodal. Now, in number 6, that one kind of has two peaks to it, and we're looking for peaks that are clearly separated. So when we're talking about two peaks, what we're really referring to is like this kind of being one peak and this being the other peak. And notice that there's a decent amount of separation in between those. And even though this peak isn't as high as the other one, there is kind of like a spike in the data at this point, which is probably important for some reason. Here we're looking at stolen base rate. So in this case, it looks like we have, there are a bunch of data kind of on this high end. And then also we have a lot of baseball players that don't steal any bases, right? So that's why we have kind of a second peak here. Because there's two peaks, we would say that this graph is bimodal. Now, sometimes, again, keep in mind that distributions might be symmetric and unimodal, or they might be symmetric and bimodal. They might be skewed and unimodal. Um, there, isn't always just one label that's going to apply. So this is the histogram that we made earlier for reaction times. And the question is asking us, what shape does this graph have? Even though it's not perfect, I mean, this peak in this graph is not exactly in the center, it does have a pretty symmetric shape where it's taller in the middle, lower on the ends. So we would say in this case that this graph is symmetric and unimodal. And one thing that you can do also is you can throw in the word approximately symmetric there. That will kind of soften your language in case it's not perfect. All right, that concludes lesson 5.1. So please do the 5.1 assignment in your homework packet.